we are looking at value engineering options. We were able to, over the last few months with Kiewit, reduce some pier foundation shafts from four to two and 6 to 4. We're also looking at some economies in the girders and superstructure design as well. They've also been able to get some additional analysis related to vessel collision, which has reduced some of the loading on the bridge, which has allowed us to do that.
We're moving the pile caps up a little bit too.
Pile caps, and this is kind of the design process, right? I mean, we're at an early stage of design. As we get more information, we'll refine the design to take that into account and continue to do that as we progress.
Can you talk a little bit about the steel casing, what it means, what it is, why it's good to get, in just very layman's terms, what is going on in the engineering of that?
So in the construction of a drilled shaft, you have a steel casing, and the thickness of it kind of depends upon the diameter and the depths and things like that it goes. And so that casing is installed, and it gets installed all the way down to bedrock, wherever that is. Remove the material inside the casing and drill out the rock and put a rebar cage and fill that up with concrete. In the early stages of the design process, they really don't take into account the structural stability that casing gives the bridge. They just look at the concrete and rebar as being its own element. And then as we refine the design, we start saying, well, what's the strength of that casing and how much does it give to the bridge structure itself? Coupled with the ship impact and refining that, and that kind of minimized a little bit. Because they were able to do some further studies about actual, what the ship traffic is on the river.
So they've changed their understanding of what impact they need to design to?
Yes. And they've refined it. And because of those things, we were able to go from 6 down to 4 shafts and from 4.
That's a big change, right? And the casings themselves, so the casings do not rust away over time?
Right.
So they'll be there forever, or as long as the bridge is there.
So, but I thought we said we're getting rid of one of the casings. I understood there was an outside casing that you vibrate down X number of feet, and then the drill shaft goes inside of that with a secondary casing.
Permanent casing.
So
and the temporary casing is removed. The temporary casing there is just to protect the fish that's on the outside from whatever's happening on the inside of that temporary casing.
Right.
Kind of like a cofferdam.
Right.
And then as far as I know, that has not been eliminated at this time.
What you're eliminating is the inside casing.
No, the inside casing, the permanent casing is going to still be there.
Okay.
We're taking that inside casing into account structurally in the.
That's allowed you to go from 4 to 2.
Yeah.
Okay, got it. The only thing that you have to do during the in-water work window is the outside casing.
Yes, and so we can just plunk those in.
The drilled shaft can be performed anytime during the year.
Timing wise, you can imagine that the outside casing could take about a day or 2 to install, while the inside casing and drilled shaft work and rock socket, rebar and concrete could be a week or 2 worth of work.
Right.
So a couple other things that are going on, the geotechnical additional borings. So now that we've got those shafts identified, they'll start to mobilize out this fall to do geotechnical borings at the locations of each one of those shafts. We did borings in 2023, which were kind of general borings just to get a initial picture of what the ground looked like underneath of there. Now that we do these additional borings, they'll do them right at the shaft so that they can get better information to see if there's any variability or differences within the shaft. So as they get that information, they incorporate it in the design. They'll continue to refine the design based on that. So that work will start up here in late October, December, or November timeframe.
We're waiting on our permit.
We're looking at
waiting on our permit.
Did you resolve the barge issue?
Not yet. Still working on it.
So we'll continue to do that.
To me, one of the key drivers is you've got to make that first in-water work window work for you.
Yeah.
So one of the things that's important in that first in-water work window is getting in the temporary access trestle and as much of it as we possibly can. And so you have to have it designed and you have to have it like ordered, and there's going to be some fabrication of it. And I mean, you guys that were out there saw how extensive that can be.
But one of the things, just, and so people have this in the back of their mind as well, right now, we have not contracted with Kiewit to do temporary, all of the temporary design that they will need to do. We've done a minimum amount because we're heading toward construction. We're trying to be financially responsible of what we're doing. However, the minute we find out we have construction, maybe I need to say this a more aggressive way. The minute we find out we have construction, there will be a big effort to change the direction of this project. And we will have major amendments, things we have to work through quickly to get them moving in a different direction so that we can make that 27, because then it becomes speed.
In an
and safety.
additional direction.
Yes, to accelerate things and move things faster. So one of the things we've been talking to them about is trying to set up the project so that we can do those early and make sure we're advancing design so that if we have to pull that trigger, we're not going, oh, wait a minute, we didn't think about that. So we're trying to make sure that those things are in place and we're advancing those much as we can by the scope we develop to be prepared for that.